A metallic rod of length L and resistance R is rotated with a frequency V with one end hinged at the center and the other end at the circumference of a circular metallic ring of radius L, about an axis passing through the center and perpendicular to the plane of the ring. A constant and uniform magnetic field P parallel to the axis is present everywhere. Okay, so for this one, first we need to know the diagram here. See, this is the diagram. Magnetic rod of length L. The length is L. They clearly showed here. If the length is L here, this is the length L. Okay, our resistance R. The resistance of this one R is rotated with the frequency of V. Okay, now this is the diagram. Enter the center, that is they are going to fix at the center here, and other end at the circumference of the circular metallic ring of radius L. That one same. Okay, about an axis passing through the center and perpendicular to the plane of the ring. Constant and uniform magnetic field B parallel to the axis is present everywhere. So the magnetic field. So this is the magnetic field. It is magnetic ring, and it is a uniform magnetic field P parallel to the axis of the present everywhere. Okay, so for this one we need to derive the expression for the induced EMF and the current in the rod. So first, the image here, then we'll go for the induced EMF, that is epsilon dash is equal to B times L into V, where epsilon is equal to B L V by 2, and epsilon is equal to B L B into L of V is nothing but L times omega divided by 2. Then epsilon is equal to B L square omega by 2. This is the EMF and the current in the rod. Okay, coming to the second part, that is, due to the presence of current in the rod and the magnetic field, find the expression for the magnitude and the direction of the force acting on this rod. Okay, we know that I is equal to epsilon divided by R is equal to B L square omega divided by 2 times R, is already know here. Then second one, that is, then force is equal to I into perpendicular distance, that is L into B. Then equation is force is equal to B L cube omega B divided by 2R. This is the force, and the direction of the force is perpendicular to both vector 1 and the vector B. Coming to the third part here, hence obtain an expression for the power required to rotate the rod. Power, we know that power is equal to P is equal to I square R, where I is equal to, we already know that is a B L square omega divided by 2 times of R whole square times R. Then our equation is B square L to the power of 4 omega square divided by P square is, that is 4 R. This is the expression for the power. Coming to the part B, a copper coil is taken out of a magnetic field with a fixed velocity. Will it be easy to remove it from the same field if its ohmic resistance is increased? Please, again, since the induced current will reduce it, it will be a little easier to remove the coil. A rectangular coil rotates in a uniform magnetic field. Obtain an expression for induced EMF and current at an instant. Also find their peak values. Show the variations of induced EMF versus angle of rotation omega t on a graph. Phi is equal to n b bar dot a bar, a vector. Okay. Then phi is equal to n e a cos omega t, where epsilon is equal to minus d phi by dt, and epsilon is equal to n dA omega sine omega t. Here epsilon naught is equal to nba omega, and we know that I is equal to omega by r, epsilon by r, which is equal to nba omega divided by r times sine omega t. That is, then I naught is equal to nba omega divided by r. Okay. Then show the variation of induced EMF versus angle of rotation omega t on the graph. See here, the x-axis represents the epsilon and the y-axis is the omega t. If it is gradually increase and decreasing. Frequency will be varying. And second part, an iron bar falling through the hollow region of a thick cylinder shell made up of copper experiences a rectangular force. What can you conclude about the nature of the iron bar? Explain. The bar is a magnetic bar because the reason is its Lenz's law is divided by induced EMF or current opposes its causes. P bar is magnetic. Bar is magnetic because reason Lenz's law upon induced EMF upon current opposes its cause, or induced EMF or current opposes its cause.